There is a book in a climate-controlled room at Yale University that roughly 240 pages long and completely unreadable. It is written in an alphabet that appears in no other document on Earth. It is illustrated with plants that match no known species. Codebreakers from both world wars have attacked it, along with linguists, cryptographers and machine learning researchers. Not one sentence has been read. It is catalogued as Voynich MS-408 and known as the Voynich Manuscript, after Wilfred Voynich, the book dealer who bought it in 1912. The single most important fact about it was not established until 2009, when a team at the University of Arizona radiocarbon dated samples of the vellum. The animal skin it is written on was prepared in the early 15th century, somewhere between roughly 1404 and 1438. That date did two things at once. It destroyed the theory Voynich himself had promoted, that the book was the secret work of the 13th century friar Roger Bacon, because the material is far too late. And it made the most attractive modern explanation much harder, because a Victorian forger cannot use vellum that was demonstrably prepared 400 years before he was born. So whatever this is, it was made by someone in early 15th century Europe who wrote roughly 35,000 words in a script they either invented or inherited, illustrated it lavishly, and left no key. The question that has consumed a century of effort is deceptively simple. Is it a language, a cipher, or an elaborate and very expensive piece of nonsense? The manuscript divides into sections by illustration style, and researchers name them by what they appear to depict rather than by anything the text says. The largest is herbal, page after page of a single plant, roots drawn in detail, with paragraphs of text wrapped around it. The format is instantly recognizable to anyone who has seen a medieval herbal. It looks exactly like a working reference book for medicine. The plants are the first serious problem. A genuine herbal from this period is identifiable. Botanists can name the species, because the whole point of the drawing was to let a reader recognize a plant in a field. Voynich plants mostly cannot be identified. Some appear to be composites, a root from one thing attached to leaves from another, which is what you get when someone is inventing plausible-looking flora rather than recording it. Other sections are stranger. There is an astronomical part with circular diagrams, stars and what look like zodiac figures. There is a cosmological section of nested circles and connected structures. And there is the section that everyone remembers, the balneological one, full of small figures bathing in green pools connected by elaborate systems of tubes and channels. One more detail matters more than it sounds. There are almost no corrections. Medieval manuscripts, even beautiful ones, carry scraped erasures and marginal fixes because scribes copying long texts make mistakes and catch them. The Voynich text runs on with a fluency that suggests either enormous confidence or a process where errors were impossible, because there was no correct version to deviate from. The strongest argument against dismissing the book as random scribbling is mathematical. Real languages have measurable statistical fingerprints that random typing does not reproduce. The most famous is Zipf's law. In any natural text the most common word appears roughly twice as often as the second most common, 3 times as often as the third, and so on down a very specific curve. Voynich's fits that curve. It goes further. The text has word lengths distributed the way real words are. Certain characters appear only at the beginnings of words and others only at the ends, which is exactly the kind of positional rule that real writing systems develop. Some sections use vocabulary that other sections do not, so the herbal part and the astronomical part have different word frequencies, the way a botany textbook differs from an atlas. That last point is the one that keeps serious researchers engaged. If somebody were producing decorative gibberish to sell to a wealthy collector, there is no obvious reason for the gibberish to change its vocabulary depending on which pictures it sits next to. The internal consistency implies the text is carrying information that tracks the illustrations. There is also a labeling pattern. Individual stars, plants and figures often carry a single short word next to them, in the position a caption would occupy. Those label words behave differently from the words in the flowing paragraphs. Whatever system this is, it distinguishes between naming something and discussing it. And then the same statistical tools produce results that no natural language should produce. The entropy of the text, roughly a measure of how much surprise each character carries, is unusually low. Voynichese is far more predictable than Latin, English, Arabic, or Hebrew. Once you have seen part of a word, you can guess the rest with uncomfortable accuracy. The repetition is the detail that unsettles people most on first contact. The manuscript contains sequences where the same or nearly the same word appears several times consecutively. Transliterated into the standard research alphabet, you get lines that read like kokety kokety dal kokety kokety. No natural language does that in running prose, and no sensible cipher produces it either, because a cipher is trying to hide structure rather than advertise it. There is another absence that has quietly killed a lot of theories. The text shows almost no evidence of the small grammatical machinery that real languages carry, the equivalents of and, of, the, that appear constantly and in predictable positions. Words also rarely repeat at the distances you would expect if the manuscript were describing the same plant part or the same procedure across many pages. So the honest position is genuinely uncomfortable. The text is too structured to be random and too regular to be a language. Every decipherment claim has to explain both halves of that, and this is precisely where the famous attempts have failed. The pattern of Voynich decipherments is consistent enough to be predictable. A researcher announces a solution, produces a translation of a few lines, and receives press coverage. Specialists then point out that the method is flexible enough to produce almost any output the researcher wants, and that it cannot be applied by a second person to a fresh page and yield anything coherent. That reproducibility test is what nothing has survived. In 2017, a television writer and researcher announced the manuscript was a women's health treatise assembled from known Latin herbal sources, with the script functioning as a system of abbreviations. Medieval Latin specialists responded that the sample translation was not grammatical Latin and that the proposed abbreviation system was not consistent with the rest of the text. In 2019, a University of Bristol researcher published a claim that the language was a lost Proto-Romance tongue. It got worldwide coverage. Linguists rejected it quickly and the university withdrew its own press release. The core criticism was familiar. The method allowed each symbol to correspond to several possible sounds, which lets the translator arrive at a chosen meaning rather than being constrained by the text. Machine learning has been pointed at it too. A 2016 study by researchers at the University of Alberta reported that statistical alignment favored Hebrew with letters rearranged within words. The resulting sample sentences were not accepted as meaningful by Hebrew scholars. The general lesson from every attempt is that pattern matching software will always find some best-fitting language, and best-fitting is not the same as correct. There is a hypothesis that accounts for both halves of the statistical problem, and its unpopularity is mostly aesthetic. Suppose the text was generated rather than written. Suppose the author worked with a method, a table or a grill or a set of rules for combining syllables, and produced text by repeatedly copying and slightly modifying what they had just written. Researchers including Torsten Timm and Andreas Schinner have shown that a self-referential copying procedure like this can reproduce the manuscript's peculiar statistics remarkably well. It gives you zip-like word frequencies, because copying propagates common forms. It gives you low entropy, because everything derives from a small pool of templates. And it naturally gives you those runs of near-identical repeated words. It even explains the section-dependent vocabulary without any meaning being present. If the author worked through the book in order, gradually drifting in which templates they favored, the herbal pages would end up statistically distinct from the astronomical pages simply because they were produced at a different point in the drift. No information required. The objection to this is cost. Vellum for 240 pages was a serious expense, the illustrations represent months of skilled work, and the writing itself is fluent and consistent across the whole book. That is an enormous investment in something meaningless. The counter-objection is that meaningless is not the same as purposeless. A convincing book of secret wisdom was a sellable object in 15th century Europe, and it did not need to work. The documented history begins late and thinly. The first solid trace is a letter in the 1660s from Johannes Marcus Marci in Prague, sending the book to the Jesuit scholar Athanasius Kircher in Rome in the hope he could crack it. An earlier letter from an alchemist named George Baresh describes owning a book of unreadable script and having wasted years on it. Marci's letter passes on a rumor, and it is worth being clear that it is a rumor reported second-hand. He mentions having heard that Emperor Rudolf II bought the book for 600 ducats, an enormous sum, believing it to be the work of Roger Bacon. There is no independent record of that purchase. The entire romantic origin story of the manuscript rests on one sentence of hearsay. So Kircher, one of the most confident polymaths of his century, was handed the problem in the 1660s and got nowhere. Then the book vanished into Jesuit collections until Voynich bought it in 1912. Every generation since has applied its best available technique. Hand cryptanalysis. Wartime code-breaking teams. Statistical linguistics. Neural networks. The result has been identical each time. The most useful way to hold it is this. We know when the vellum was made. We know the text is not random. We know it is not a straightforward substitution cipher, because those fall to frequency analysis in an afternoon. And we do not know whether there is any meaning inside it at all. After 100 years of the best cryptographers on Earth, the honest summary of the Voynich Manuscript is that we cannot yet tell the difference between a message nobody can read and a book with nothing to say.